Hi everyone, my name is Miss Duffy and I'll be your algebra teacher for Winter Break Academy. This is going to be our first lesson video for Unit 1 on types of sequences. Unit 1 is called Sequences and Series. Alright, so what is a sequence? A sequence is just an ordered list of numbers, so numbers listed in a specific order. And each number in the sequence is called a term. So there'll be a first term, a second term, a third term, fourth term, and so on. Sequences can come in many different types. So sequences might have a pattern, like this sequence 2, 4, 6, 8, 10, and so on. The pattern here is +2. Because I'm adding 2 each time to get from term to term. Sequences might not have a pattern though, they might be totally random, so we could have like 1,000, -50, 2, 7, -5, and so on. So this sequence is just random. Those sequences aren't very interesting. We generally are interested in sequences that have patterns. Sequences might be finite, which means that they stop. So if you have just a limited number of terms in your sequence, so like 4, 3, 2, 1, 0, stop, that's a finite sequence because it cuts off, it doesn't continue. Or sequences might be infinite, which means that they never stop, they continue forever and ever and ever. So an example of that might be like 2, 4, 8, 16, 32, 64. We're multiplying by 2 forever and ever and ever. So infinite means that it never stops. You can keep multiplying by 2, so this sequence could continue forever. Okay, so that's just a general overview of what sequences are. In this class, we're going to be focusing mainly on some special types of sequences. The first special type of sequence is called an arithmetic sequence. And an arithmetic sequence is where you are always adding by the same number to get from term to term. So think arithmetic adding. So our first example here, 7, 17, 27, 37. To get from 7 to 17, I add 10. Then to get from 17 to 27, we add 10. 27 to 37 is also plus 10. So we're always adding 10. We're adding by the same number every time. So that makes this an arithmetic sequence. And this number 10, we call that the common difference, the number that you're adding. So that's a basic example where we have a positive common difference. We can sometimes have arithmetic sequences that have a negative common difference. So for example, from 100 to 96, we subtract 4. 96 to 92, subtract 4. 92 to 88, subtract 4. So this is also an arithmetic sequence because we can think of subtracting 4 as adding -4. So we're still adding by the same number. The number we're adding by is just negative. So in this case, we would have a negative common difference. And it would be -4. All right, so that's arithmetic. The next type is a geometric sequence, and in a geometric sequence, you are always multiplying by the same number. So instead of adding, we multiply. So for example, our first sequence here, from 1 to 2, we multiply by 2. 2 to 4, we multiply by 2. 4 to 8, multiply by 2. 8 to 16, multiply by 2. So we're always multiplying by 2 to get the next term. That makes this a geometric sequence. And in this case, we call this 2, the number we multiply by, the common ratio. So whatever you multiply by, that's the common ratio. So just like with arithmetic, we could have addition or sort of subtraction. With multiplication, we can also sort of have division because we can multiply by a fraction. So 27 to 9, you could think of that as dividing by 3, or you could think of it as times the fraction 1/3. 9 is 1/3 of 27. Then 9 to 3, also multiplying by a third. 3 is 1/3 of 9. 3 to 1 times 1/3, 1 to 1/3 times 1/3. So we're always multiplying by 1/3. So in this case, we would have a common ratio of 1/3. If you see a sequence that appears to be dividing by the same number every time, it's a geometric sequence and the common ratio is a fraction. So if you're dividing by 3, common ratio 1/3. If you're dividing by 7, common ratio 1/7. All right, the last type of special sequence that we're going to look at is called a shifted geometric sequence. And this basically combines arithmetic and geometric. You're going to have a number that you multiply by and a potentially different number that you add by. But the number you multiply by and you add by are the same every time. So these are a little bit more complicated to recognize. But from 1 to 4, we could get from 1 to 4 by multiplying 1 by 3, so 3 times 1 is 3, and then adding 1. And we could get from 4 to 13 by multiplying 4 by 3 to get 12, and then adding 1. 13 to 40, we could multiply 13 by 3, that gives us 39, add 1 to get to 40. 40 to 121, if we multiply 40 by 3, we get 120, add 1, we get 121. So in this case, the pattern is times 3 plus 1. So we're always multiplying by 3 and then adding 1. So that makes it shifted geometric because we multiply and we add. All right, let's look at one more example of that. So to get from 8 to 11, I could do, it's a little hard to figure out sometimes, but we could do 5 times, or not 5, oh my gosh, 2 times 8. That gives us 16, and then subtract 5. Okay, let's see if that works. So 2 times 11 would be 22, and then subtract 5 would give us 17. 2 times 17 would be 34. Subtract 5 would give us 29. 29 to 43, so 2 times 29 would be 48, minus 5 gives us 43. So this time we're always multiplying by 2 and subtracting 5, or you could think of it as adding negative 5. So times 2 minus 5. All right, so that's a quick overview of what sequences are and 3 special types of sequences.